Hello children, hope you all understood limits and to evaluate the limits. In this video we are going to see about derivatives, which is very important. We have seen that by knowing the position of a body at various time intervals, it is possible to find the rate at which the position of the body is changing. It's very common to know a certain parameter at various instants of time and try to finding the rate at which it is changing. For instance, people maintaining a reservoir need to know when will a reservoir overflow, knowing the depth of the water at several instances of time. Financial institutions need to predict the changes in the value of a particular stock, knowing its present value. In many such cases, it is desirable to know how a particular parameter is changing with respect to some other parameter. The heart of the matter is derivative of a function at a given point in its domain of definition. Suppose f is a real valued function and a is a point in its domain of definition. The derivative of f at a, which is denoted by f dash of a, and it is defined by limit h tends to 0 f of a plus h minus f of a by h, provided this limit exists. So derivative of f of x is denoted by f dash of x. Here a is a point in its domain of definition. So derivative of the function is f dash of a. Observe that f dash of a quantifies the change in f of x at a with respect to x. Derivative of a function f dash of a, which is a change in f of x at a with respect to x. For example, we have to find the derivative at x equal to 2. The function is 3x. F of x equal to 3x. So f dash of x, which is derivative of f of x, which is equal to limit h tends to 0 using the result f of a plus h minus f of a by h. Here x equal to 2. So x tends to 2. So f dash of 2, which is equal to limit h tends to 0 f of 2 plus h. In the place of x, we have to replace this as 2 plus h. So f of 2 plus h minus f of 2. So what is f of 2 plus h? In the place of x, we have to replace 2 plus h. So 3 into 2 plus h. And f of 2 is 3 into 2. So we have to write this as limit h tends to 0, 3 into 2 plus h minus 3 into 2, 6 by h, which is equal to limit h tends to 0, 6 plus 3h minus 6 by h. 6 will get cancelled, h and h will get cancelled. So we have limit h tends to 0, 3, which is equal to 3. So the derivative of the function f of x, which is equal to 3x at x equal to 2, which is 3. That is f dash of 2 equal to 3. Second definition. Suppose f is a real valued function. The function defined by limit h tends to 0 f of x plus h minus f of x by h. Wherever the limit exists, it is defined to be the derivative of f at x, which is denoted by f dash of x. This definition of derivative, which is also called first principle of derivative. So f dash of x equal to limit h tends to 0 f of x plus h minus f of x by h. There are different notations for derivative of a function. Sometimes f dash of x is denoted by d by dx of f of x, or if the function is given as y equal to f of x, so derivative of a function y which is denoted by dy by dx. This is referred to as derivative of f of x or derivative of y with respect to x. It is also denoted by capital D of f of x. Further, derivative of f of x at x equal to a, which is also denoted by d by dx of f of x, or df by dx, or df by dx at x equal to a. Algebra of derivative of functions. The rules for derivatives to follow closely that of limits. Theorem 5. Let f and g be two functions such that derivatives are defined in a common domain. First one, derivative of sum of two functions is sum of the derivative of the functions, that is d by dx of f of x plus g of x, which is equal to d by dx of f of x plus d by dx of g of x. Second one, derivative of difference of two functions, which is difference the derivative of the function, that is d by dx of f of x minus g of x, which is equal to d by dx of f of x minus d by dx of g of x. Third one, derivative of product of two functions given by the following product rule. D by dx of f of x into g of x, that is product of two functions, which is equal to d by dx of f of x into g of x plus f of x into d by dx of g of x. D by dx of g of x refers that we have to differentiate g of x and we have to multiply with f of x. Here we have to differentiate f of x and we have to multiply with g of x. This statement can be restated like u equal to f of x and v equal to g of x. Then we can rewrite this as uv whole dash, which is equal to u into v dash plus v into u dash. V dash refers that it's d by dx of v. So this can also be written as u into dv by dx plus v into du by dx. So v dash means we have to differentiate once. So u into dv by dx plus v into du by dx. This is referred to a Leibniz rule for differentiating product of functions, or this is called product rule, which we are going to use everywhere in the derivative of a function. If any two functions are given to find the derivative, we have to use product rule. Fourth one, d by dx of f of x by g of x, which is equal to g of x into d by dx of f of x minus f of x into d by dx of g of x by g of x whole square. U equal to f of x and v equal to g of x. So u by v whole dash, which is equal to v into u dash minus u into v dash by v square. Derivative of f of x, which is equal to x. F dash of x equal to limit h tends to 0 f of x plus h minus f of x by h, which is equal to limit h tends to 0 x plus h minus x by h. So limit h tends to 0 1, which is equal to 1. We use this and the above theorem to compute the derivative of f of x equal to 10x. We can write 10x as x plus x till 10 times. That is, we have 10 terms of x. So we can write d by dx of f of x. That is, we are differentiating f of x. So d by dx of x plus x till x, 10 terms. So d by dx of x is 1. So 1 plus 1 plus 1 till 10 terms. So we have 10. So d by dx of f of x, which is equal to 10. Differentiating f of x, we get 10. We note that this limit may be evaluated using product rule. Right? F of x equal to 10 into x. So 10 we can take it as u and x as v. Where u is a constant function. Here 10 is a constant function. When we differentiate 10, it is 0. Also, derivative of v, that is d by dx of v is, d by dx of x is 1. Here u is 10 and v is x. Differentiating u, we can either write du by dx or u dash. U dash is, when we differentiate constant, it is 0, and dv by dx or v dash. When we differentiate v, that is d by dx of x, which is 1. So u into v dash plus v into u dash. The formula for product rule. U into v dash, 10 into 1 plus v into u dash, x into 0, which is equal to 10 plus 0, which is 10. Theorem 6, derivative of f of x, which is equal to x power n, which is nx to the power of n minus 1 for any positive integer n. By definition of the derivative function, we have f dash of x equal to limit h tends to 0, f of x plus h minus f of x by h, which is equal to limit h tends to 0. We have to replace this as x plus h. So x plus h whole power n minus x power n by h. So using binomial theorem, x plus h whole power n, which is equal to nc naught x power n plus nc1 x power n minus 1 into h, etc. ncn into h power n. Therefore, x plus h whole power n minus x power n, which is equal to h into nx to the power of n minus 1, etc. h to the power of n minus 1. Then f dash of x, which is equal to limit h tends to 0, x plus h whole power n minus x power n, which is h into nx to the power of n minus 1, etc. h to the power of n minus 1 by h. Cancel h. We have limit h tends to 0, nx to the power of n minus 1, etc. till h to the power of n minus 1. As h tends to 0, so this will become 0. Then f dash of x equal to nx to the power of n minus 1. So d by dx of x power n. Here f of x equal to x power n. F dash of x is nx to the power of n minus 1. For example, f of x equal to x power 2. We have to find the derivative of x. That is, we have to find f dash of x. Derivative of x power n, which is equal to nx to the power of n minus 1. Here we have x power 2. N is 2. So 2 into x power 2 minus 1, which is 2x. Suppose we have to find derivative of x power 3. Then it is n is 3. So 3 into x power 3 minus 1, which is 2. Suppose we have to find x power 4. Derivative of x power 4. Then using the same formula, 4 into x power 4 minus 1, which is 3. So otherwise we can differentiate this using the product rule. F of x equal to x square use x into x. Using the product tool, take u as x and v as x. Differentiating u dash, we get 1. Differentiating v dash, we get 1. So the formula is to find uv dash is u into v dash plus v into u dash. So x into 1 plus x into 1, which is equal to 2x. So either you can use this formula or the product tool. Derivatives of polynomial function. Let f of x equal to a n x power n plus a n minus 1 x power n minus 1 plus etc. a1x plus a0 be a polynomial function where a1x are all real numbers and an is not equal to 0. Then the derivative of a function is given by d by dx of f of x, which is equal to nan x to the power of n minus 1 plus n minus 1 a n minus 1 into x power n minus 2 etc. 2a2x plus a1. Derivative of trigonometric function. So we have different formulas for the trigonometric functions. So let's do first derivative of sin x. Let f of x equal to sin x. Then we know that f dash of x equal to limit h tends to 0 f of x plus h minus f of x by h, which is equal to limit h tends to 0 sin of x plus h minus sin x by h. So using the formula sin a minus sin b, here a is x plus h and b is x. Sin a minus sin b, which is equal to 2 cos a plus b by 2 sin a minus b by 2. So which is equal to limit h tends to 0 2 cos a plus b by 2 x plus h plus x, that is 2x plus h by 2 into sin a minus b x plus h minus x, that is h by 2. Bring this 2 to the denominator and limit h tends to 0 cos of 2x by 2 is x plus h by 2. Limit h tends to 0 sin h by 2 by h by 2. Using the result, limit x tends to 0 sin x by x equal to 1. This will become 1. So we get limit h tends to 0 cos of x plus h by 2. Put h equal to 0, we get cos x. So d by dx of sin x is cos x. Similarly, d by dx of cos x is minus sin x. So this thing you can do on your own and just verify your answers. Let me compute the derivative of another function, which is tan x. Let f of x equal to tan x, f dash of x equal to limit h tends to 0 f of x plus h minus f of x by h, which is equal to limit h tends to 0 f of x is tan x, so we are writing tan of x plus h minus tan of x by h. Tan x is sin by cos, so sin of x plus h by cos of x plus h minus sin x by cos x. From this we get limit h tends to 0 1 by h of sin of x plus h into cos x minus cos of x plus h into sin x by cos x cos of x plus h. Using trigonometric results, sin of a minus b equal to sin a cos b minus cos a sin b. Here a is x plus h and b is x. So we can write this as sin of a minus b. A is x plus h and b is x by cos x into cos of x plus h. We can cancel x. So we get limit h tends to 0 1 by h of sin h So sin h by h. Limit h tends to 0, sin h by h, using the result which is 1, into limit h tends to 0, 1 by cos x of cos x plus h. As h tends to 0, this will become 1 by cos x into cos of x. H will become 0. So 1 into 1 by cos square x. So 1 by cos square x is secant square x. So d by dx of tan x is secant square x. Similarly, you can find the derivative of secant x, cosecant x, cot x, etc. We'll see the formulas in the next video. Thank you, children.